好的，那么接下来呢，就要欢迎我们今天的第一位讲者哦。我们今天的第一位讲者，他远道从日本而来，那么他是带领日本 Node.js 使用者发展的社群之外呢，他也是东京 Node 学园季的发起人之一哦。那么他对 ESNet 还有 WebRTC 等测试工具和新协议相当的感兴趣，那并且还有自己构建一些教程工具哦。那么接下来呢，就让我们一起热烈的掌声欢迎我们今天的第一位講者 Yosuke Furukawaさん。Yosukeさんを歓迎しましょう。
Hi. This is the first time to travel to Taiwan, and I'm very excited to stand here. And thank you, JSDC, and thank you, Ari, and all other staffs. So yesterday, I ate xiaolongbao. Yeah, that is so delicious, and very reasonable cost, and I love Taiwan. And my talk title is Turbo Boost Next Node.js. And I would like to introduce Node.js performance deeply. Yeah. And before this talk, let me introduce myself. My name is Yosuke Furukawa, and the Twitter handle is Yosuke_Furukawa, and the GitHub handle is Yosuke-Furukawa. It's mostly the same. And my true name is here. You can see here. And I think in Taiwanese word, in Gu Chang Yang Zi, is correct? Gu Chang Yang Zi. Yeah. Yes, this is my name. Yeah, and I'm Node.js Japan user group leader. So I have a very important news. We Node.js Japan user group has a festival for the Node.js. The name is the NodeFest. We will hold NodeFest on November 25th and November 26th. So if you are comfortable, so please join us. We have already opened our attend page. Please go to http://nodejs.jp, nodefest.jp/2017. So oops. Here is the attendance page. So you can go up. I got it. Here is the attendance page. So nodefest.jp/2017. So if you have interested in our conference, please go here and here. Okay. Let's back to my talk. Okay, so let's back to my talk. And my talk title is Turbo Boost Next Node.js. Node.js current and future version had some features for performance. And I would like to introduce those performance features. Here is the Node.js inside. Node.js depends on some libraries. The standard libraries are like file system and FS, child process, and HTTP, HTTPS, etc., etc. That part is mostly written in JavaScript. And those standard libraries depend on other lower libraries like an NAPI, and V8, and HTTP parser, and etc., etc. And V8 is to compile JavaScript, and HTTP parser for HTTP, and CRS for DNS, OpenSSL for cryptography, and zlib for compression, and NGHTTP2 for HTTP2. The LibUV creates an event loop model. And today, first point is here, V8. So V8 is a JavaScript engine for Chrome and Node.js. V8 is powered by Google. V8 has renewed their JavaScript optimizer. Yeah, I will introduce V8 Next optimizer. So this is the introduction of optimization. First of all, V8 tries to optimize code on runtime. And however, JavaScript is dynamic typed language, as you know. Optimized code has some dynamic checks to validate their assumptions. If a dynamic check and a validation are failed, V8 de-optimizes code. So I will explain how V8 optimization in detail. So here is a sample program. This is a very simple. The function x has an argument object, and return the object.a plus object.b. And we call x function like this. So x a clone 1 and a b clone 2 and some things here. The first, V8 runs the code for gathering feedbacks. So this is a V8 down. V8 gets this function has 2 props, and all values are number. And if this function is called so many times, V8 thinks this function is hot function. So when the function is hot, V8 optimizes this function. So like this, V8 optimizes this x function. The one need to load a and b props. A and b value is number, and summarize a and b and return the value. So, however, JavaScript can take dynamic parameters like a clone how to Xiaolongpo is not a number. It's right? Yeah. So, yeah, the V8 is shocked. Oh, my optimization code has gone. And need to go back to unoptimized code. This is called de-optimization. So we need to avoid this de-optimization to write your code faster. So previous optimizer is named Crankshaft. First of all, JavaScript source code is passed by V8 parser, and passed code will be abstract syntax tree. The abstract syntax tree is compiled by Furukawa compiler. This compiler outputs unoptimized machine code. If the function is hot, Crankshaft compiler optimizes the code to optimized machine code. But this Crankshaft has some problems. Crankshaft code is very legacy, so it is hard to support ECMAScript new syntaxes. And Furukawa generates unoptimized machine code, but it produced a lot of codes, so memory cost is very heavy. And there are many potential risks for the optimization. So previous Node.js, we cannot use let and const, and we cannot use less and split parameters. And we cannot use try catch and try finally syntaxes. And we cannot use a for in, because that is not so fast. And if just-in-time killer kills the optimizer, so the optimization goes down to terrible performance. So categorize that. First 2 problems indicates the Crankshaft doesn't support ECMAScript syntaxes. And next 2 problems indicates there are some potential risks of optimization killer. If optimization killer kills the optimizer, the optimization is executed. But the cost is so high. I will show you a demo. Oops. I have learned. here is the normal function that is so simple, but it uses a rest parameter, right? Dot arg is a rest parameter. And returns parameter index 0. That is so simple, but before Node v6.0, we cannot use this function fastify. So here, okay. We will try to optimize this function, but Node version v6.9 doesn't support this parameter, so we cannot optimize it yet. But we have next optimizer. V8 team needs to fully rewrite their optimizer. The optimizer name is the tabfun and the ignition interpreter. This is a diagram to show you how new full-rewritten V8 works. So new V8 is here, but is it so similar to previous one? Yeah, yes. It is not so different. The different point is 1 point. The here, ignition interpreter generates the bytecode. So, and the tabfun compiler optimizes from the bytecode to the machine code. As a result, many problems are solved. Tabfun can support ECMAScript new syntax, and bytecode does not need so much memory. So ignition interpreter makes memory efficient. And the optimization risks becomes lower. So every problems are solved. I will show you the evidence. Sorry. Oops. Where is my code? Oops. I got it. Oops. So the previous code is the REST code, and oops. That is the previous result, but our Node.js will be Node preview uses latest mode. So we are using the Node.js v9.0. So that's so Node allow native syntax test.js and Node version v9. We can optimize the REST parameter codes, and as a result, that is very faster than the previous version. So I will show you the benchmark result. This Node Node v6 uses Node v6.9. And yeah, benchmark code is here. Then the Node v6.9 benchmark result is 19.645 milliseconds. But here is the result. So the latest Node.js, the benchmark result is 6.118 milliseconds. So using the rest parameter. So you can use rest parameter in Node v9 and you want to make more fast than the code. Okay. It's okay. Oops. Sorry, my keynote is gone. Oops. Okay. So all problems are solved by TabFun. Okay. And this is the user voice to update Node v9. So Node v9, his HTTP benchmark is faster, 15 through 20% than Node v8. And new v8 and TabFun makes Node.js code faster. And this is a memory comparison, Crankshaft and TabFun. TabFun is lower than Crankshaft about memory usage. Okay, I will introduce next point. Node.js v8 and Node.js v9 supports the HTTP2. HTTP2 is the next HTTP protocol. So yeah, I will. HTTP next protocol is supported by next Node.js as long as HTTP2. So before this talk, I would like to introduce the HTTP 1.1 problems. So every modern browser can send to requests to servers parallelly like this. So get/main.js, get/main.css, image available.png. But browser can send only 6 requests. If you need to send more requests, other requests are blocked, and they need to wait to finish previous request. And if one request is slow, browser can use only 5 requests until the request is finished. This is a HTTP 1.1 problem. So this problem is named Headofline Blocking. And HTTP2 solves this Headofline Blocking. HTTP2 can send requests over 6 requests on one TCP connection. If some requests are slow, but whole requests are not affected. So I will show you this demo. Yeah, this is my Twitter account. Please follow me. And oops. 3万になってる。Error. Okay. It's very hard to write a code. Yeah. Okay. Yeah, it's a pretty cool character for Go. So I will show you the HTTP 1.1 problem. Here is the problem. So HTTP 1.1 can request only 6 requests. And if the network is very slow, so you can see the image like this. Because, yeah. And you got the, oops, yeah. You get the DOM completed in 17 seconds. And I will tune this to the HTTP2. Okay, I will update this to the HTTP2 mode. Reload it. Here is the HTTP2 mode. That is not so, that is only 2 seconds. You got it? And I will show another example. So HTTP2 has a push response. So I will show you the demo, the HTTP2 with push. Oops. Here. Okay, 1.7 seconds. This is the fastest in my demo. Yeah. Oops. Okay. As you can see, so HTTP 1.1 is 74 seconds to load page. That HTTP2 becomes more faster. HTTP2 loads the page for about 2 seconds. And HTTP2 with push becomes more and more faster. This page is completed for 1.7 seconds. This is the HTTP2 power. And next is the last topic, the future. The future node has support worker. Worker will come in the next node, maybe V10 or V11 or something. So IO.js, the friendly fork for Node.js, has the implementation for the worker. Node.js has some proposals for worker. Node.js has various use cases like that. Everyone uses a bubble, and the bubble targets files are increasing day by day. And React and Angular and Vue.js, some things, other frameworks need server-side renderings. And today's topic has a server-side rendering topic, I think, yeah. And the Webpack and Gallop and Grunt needs more efficiency. So every tools, every framework has CPU-intensive tasks. But Node.js is the single process and the single thread. So before v0.5, Node.js is only single process and single thread. But Node.js v0.6, we can use the child process and cluster. The master process can fork child process in a v0.6. And this is next. Node.js may support worker. Worker is not process. Worker is based on the thread, the multi-thread. So master process can make new worker, thread. And the worker generation cost is cheaper than shared process, and can share the memory using the shared array buffer. And I will benchmark the bubble using the worker and the IO.js. This is a normal bubble. Bubble core using the single thread. So the left one is the target files, the EX written in ES6, and the bubble transpiles the code to the ES5. And those files executed sequentially. But we can use the child process in current Node.js. So master process sends each file to each child process, and child process executes bubble and returns the transpiled results parallelly. The last one is worker model. That is a simple model. That is similar to child process model, but that is using worker. And I will show you the result. Here is the result of comparison using the single thread, child process, and worker. If your target files less than 100, single thread model wins. That is a normal bubble. But I guess you have lots of ES6 code in you want to write single page applications. However, target files more than 100, worker wins. So that is the result. Okay. I will show you some example. And, I cannot find my example code. Sorry, wait. Here is the example code, and so if your file is only 1 or 10 files, you can get the bubble result in 7.1592 milliseconds. But oops. Oops. So we have an 1,000 code in under the fixtures, and that is a 1,000 ES6 code, JavaScript code. So that if you have more than 1,000 code, you can get the okay. So you can almost 11 seconds to transpile the all codes. But if you are using worker, you can reduce the cost. Here, only 4 seconds. That's it. So as you can see, so target files more than 100, you can worker can reduce your cost. To summarize that, Node.js has some performance features. V8 keeps improvements the JavaScript performance. Tab fan and the ignition interpreter is very fast, blazing fast. HTTP2 will solve head-of-line blocking. HTTP network is more faster than the previous one. And the future Node.js may support worker. Worker can use CPU more efficiently. So thank you so much. to write hearing my slide. That is the difference. If you have interested in examples, please check this code. Okay, thank you so much.
好的，非常谢谢 Yosuke 想为我们带来的分享哦。那么现在想要问问现场有没有会众呢？有问题想要向他做进一步的请教的，那我们可以直接的举手发问。那并且我们今天主办单位以及我们的赞助商也有准备一些小礼物，想要提供给有发问的大家。所以现场大家有没有问题想要问的？有吗？还是大家想要看一下礼物才愿意发问？大家可以看一下，这是Carousel 提供的小礼物，非常的可爱。哎，后面有一个问题，我们请工作人员递麦给你。
Questions? Yeah, I got it. Please come in, not fast.
Hello.
Hello.
I have a question here. I'm actually confused because you said that in the future, Node.js is going to support Worker.
Yeah.
However, I saw that Worker has been used by various projects like Jest or perhaps JS Crankshaft.
Yeah.
But what do you mean by that? It will be supported later.
Yeah, and currently, so Node.js doesn't have an actual roadmaps to support Worker, but Node.js Collaborator Summit in October 3rd. So we are discussion about the Worker, and probably Node.js will support in Worker in V10 or V11. So because some collaborators have very passion to the support Worker, and if the support is if support to the workers, so we can see the bubble and the ground and some things is more efficiently. So everyone want to Node.js more faster and faster. So we need to get the more feedbacks about the Worker. So please use if you want to have an interested in Workers. So please use the AO.js one, and if you have some more opinions, please feedback the AO.js. So we will support the Node.js core. Is that okay?
好的，那还没有其他会众有问题想要向我们的 Yosuke 想做进一步的请教，有吗？不用害羞，如果有问题的话，可以直接的提出。好，那如果没有的话，我们就要以掌声谢谢我们 Yosuke 想带来的分享。ありがとうございます。
谢谢。